This is video 3.4, so now we're in the second half of our unit on the mole. The last three videos in this unit are going to be about applications with the mole. So this first one is percent composition. So as we get into some of the work, if you have calculated molar mass like I taught you to and showed you, this is going to be super easy because it's just one little extra step to do from the molar mass piece. So what is percent composition? It's the percent by mass. And that's the key word. All right, percent by mass of each element in a compound. Okay, percent composition is the same. All caps there. It's the same. I'm going to highlight it. It's the same regardless the size of the sample. So what that means is that if you have water, okay, for example, water is 11% hydrogen, 89% oxygen by mass. That is true. That percentage is the same whether you have a drop of water or you have a bucket of water. It's still 11% hydrogen, 89% oxygen, regardless the size of the sample. Okay, so how do we calculate percent composition? Well, percent, whenever you hear that term, we've already done percent before. It's always part over whole. Okay, this is just a different application of it times 100. Where the part is the mass of the individual element. The whole is the mass of the compound. Okay, so figure out each individually, so we need our molar mass, and then we can kind of go from there. So first step, so if we're going to figure out the percent composition of copper 1 sulfide, calculate the molar mass first. So I've got copper and I've got sulfur. Those are my two elements in my compound. So figure out how many atoms. I've got 2 atoms of copper, I've got 1 of sulfur. Multiply by their individual element mass or atomic mass. So 63.45, and sulfur is 32.07. All right, well that math is easy for sulfur. Copper, when you multiply by 2, you should get 126.90. Okay, same thing. Add it up. So when we add those up to get the sum, we get 158.97 grams per mole. All right, so that's the first step. Start with the molar mass. Now we can figure out the percent of each element. All right, so copper, its part was 126.90. All right, divided by the whole, which is the molar mass that we calculated. So 158.97 times 100. Part over whole times 100. When you do your math for percentages, it's okay to round to 1 decimal place. You might see multiple choice where it's a whole number. All right, but to be safe, 1 decimal place. Don't worry about sig figs with it. You wouldn't be asked proper sig figs with percent composition. 79.8% copper is what we should end up with. Okay, oops, and I didn't write that correctly. 79.8%. So do the same thing with sulfur. Okay, sulfur was 32.07 for the part. The whole, again, is the same whole, because, right, it's the same compound, times 100. So when you do that math, you should end up with 20.2. Let's see if this is going to work. It's driving me crazy already. 20.2%. Now, you can check your work. All right, do the percentages add up to 100? Remember, with this, if they don't add up to exactly 100, guys, or close, right? If they're off by 0.1%, so if you get 99.9, that is acceptable. If you get 100.1, that's fine. If you get something like 97%, go back and double check your math. Make sure you didn't mix something up. But yeah, that's pretty much it. So I would encourage you guys to pause the video, try barium chloride on your own, and then come back and see how to work it out. So barium and chlorine. So I've got 1 barium, I've got 2 chlorines. The molar mass of barium is 137.38. It's easy math. 137.38. Chlorine's mass is 35.45. Probably are starting to remember some of these elements the more that you do their masses. All right, so when you multiply by 2, it's 70.9. So we've got to add them up, right? Get the molar mass, 208.28 grams per mole. Now, if you have done the work like I'm showing here, like I've done all along with molar mass, notice you have the fraction that's needed for chlorine right there. So all you have to do then for percent composition is tack on times 100, and bam, now you can figure out your percentage. So this would be 34.1%. So if we want to do the same thing for barium, I could just rewrite it, put my total, my whole on the bottom, times 100 equals 65.9%. Okay. Now, one thing I want to point out, every year on the Regents, you're asked to, or a lot of times each year, they ask you to do and show your work or for the setup of percent composition. I circled in purple the times 100. I can't tell you how many students of mine last year missed easy points because it asked for the setup and they forgot to put the times 100. Okay? Make sure, guys, you're going to see this as we go along. A lot of Regents questions, they only ask you for the setup. So if they only ask you for the setup, you don't have to worry about the final answer. If you forget a step, something so easy like times 100, you will lose all credit because it's part of the setup to get to a percent. Okay, so make sure you take your time and show all of your work so that you're not losing easy points. If you did not pause the video for barium chloride, pause it now and get your molar, see what the percentages are for the 3 elements here in sodium phosphate. So I've got sodium, I've got phosphorus, and I've got oxygen. So 3 sodium atoms multiplied by its atomic mass, 22.99. That's going to give me 68.97. Oh, here we go. Okay, that's the mass that sodium brings. Phosphorus, I've got one of those. Its mass is 30.97. It's easy math. Oxygen, 4 times, you probably have this one memorized, 16. So that's going to be 64. When I add them all up, my entire mass, my total mass would be 63.94. So then I can just, that's easy there, times 100. So I can just rewrite all of my fractions. So 163.94 in parentheses times 100. Making sure that I'm showing all of my work so I don't miss easy points on the Regents or on my quizzes. And then what are our percentages? So sodium, you should end up with 42.1%. Phosphorus, you should have about 18.9%. And then oxygen should be 39.0%. All right. So that's all I've got practice-wise. You guys go ahead and do practice 6, and I'll catch you in the next video.